So the current, so this is 8.3 in our text, which is logical operators, and, or, and not. Let's start with simple stuff. Let's go ahead and say, let's look at the not value. Not, given a Boolean, produces the opposite. So let's go ahead and print out true. No problem. True. All right. Well, what is the so not true? This gives us the opposite of true, which would be false. Fairly simple. That's pretty much as complicated as it gets. Where if we say not false, that's going to be true. Again, that's as complicated as it gets. Although you can make it more complicated. Although why would you? Also, by the way, if you know what I'm talking about, De Morgan's law does apply when we work with ands and ors. So, not false. Well, first off, what is not true? Not false. It's false, right? Not false is true. So not false is false, right? The nots cancel each other. Two nots will cancel each other. So not false is false. Right? They'll just cancel each other out. Okay? That would be a question on an exam if I was given an exam on paper where you couldn't look anything up or didn't have access to a compiler, but it's kind of moot when you have access to a Python interpreter. So we aren't going... But anyway, it's super useful. Often we'll use it when we use a while statement, which keeps going while the Boolean expression is true. So, for instance, I might say something while done is equal to false. And the condition is while not done. I'll use this a lot when I write while loops. Okay, but the interesting ones are and or. Okay, so let's go ahead and say x is equal to. X is equal to true. Y is equal to false. So let's go ahead and print out. Let's go ahead and print out x is equal to print out x and y. I was just thinking for a second I could use a nested for loop here. So x and y, that gives us false. If I say false and false, that gives us false. True and true, though, give us true. So what is and? And is a logical operator. It takes a Boolean statement on the left and a Boolean statement on the right. Given those two Boolean expressions on the left and the right, if the left and the right are both true, it will produce true. Okay? So, if x is true and y is true, x and y is true. If any of those are false, so if x is false, y is false, or both x and y are false, the entire thing is false. Right? So let's go ahead and see. For instance, let's go ahead and do x is equal to 8. Print out x is greater than 5 and x is less than 20. Both those conditions are true. So it prints out true. But if we print out 90, well, x is greater than 5 is true, but it's not less than 20. So that part is false. So true and false gives us false. So this entire expression is false. Now, on the other hand, if I were to do a statement like or is a bit different. Or is pretty cool. So, or, one of them, if any single one of these are true in or, then the whole statement is true. So x is true, X or Y? Well, since X is true, the entire thing is true. What about Y being true, but X being false? Still true, because one of them is true. What about if they're both true? Well, then if it could be extra true, it would be, but you can't be extra true, so you're just true. Thank goodness my kid is asleep at this point, because otherwise he'd want to watch that true show on Netflix. False or false. If they're both false, then the entire thing is false. So here's a common operator we might see. Let's go ahead and grab this from the textbook. N is equal to 25. If n mod 2 equals 0 or n mod 3 equal a lot going on there. That's why I like this one, because it just jumps and throws you straight into the fire. All right, so first off, n is the number 25. So if n mod 2, what is n mod 2? It is the remainder if we divide n by 2. What's the remainder when we divide n by 2? 25 by 2. If you divide it by 2, remainder is 1, right? It can only be 0 or 1 if you mod by 2. Well, it's not an even number, so we're going to have 1 left over. So this statement is false, right? Because n mod 2 is not equal to 0. It's 1. Or n mod 3 equal to 0. So n is 25. 25 mod 3. What is the remainder of 25 after it's been divided by 3? Remainder of 25 after being divided by 3 is also 1. Because 24 is divisible by 3, but not 25. So both sides of those are false, so the entire thing is false. Now, let's go ahead and let's go ahead and change this number to see what we are doing. 9. So that was true this time. The remainder after dividing by 2 is 0. Sorry, the remainder after dividing by 2 is not 0. It is 1. It's checking to see if it's equal to 0. If n mod 2, what is n mod 2? 9 divided by 2 gives us something, remainder 1, 4 remainder 1. 1 equals 0, not true. 3 divided by 3 gives us, 9 divided by 3 gives us 3 remainder 0. So the remainder is equal to 0. So what effectively this does is this is asking if the number is divisible by 2. That is what this is asking. Or the number is divisible by 3. So if the number is divisible by 2 or 3, it will output true. So 800 is divisible by 2. 801 is divisible by 3. I know that. How did I say that so confidently, by the way, that 801 was divisible by 3? I can tell very quickly. I also know that 804 is divisible by 3. I'm just adding there. Let me type up another number and see if it's divisible by 3. So let's go ahead and do 117. That number is divisible by 3, yes. That is a bit of a big number, but let's see there. So, So, I'll teach you the trick in just a second. So, 7, and then 14, 19, 27. I think that's divisible by 3. It's a big number. I know it's divisible by 2, but let's go ahead and see if it's divisible by 3. False. It's not divisible by 3. So I just simply did my addition wrong. So, yeah, no, it's not divisible by 3, of course. Yeah, I did my addition wrong. It's 27. 3. 16, 21, 29. Yeah, did my addition totally wrong. All right, so the trick, by the way, to tell if a number is divisible by 3 is you can take the number and add all the digits together, and if that number is divisible by 3, then the entire thing is divisible by 3. I'm serious, right? So, for instance, 45 is divisible by 3 because they add up to 9. 17 is not divisible by 3. Let's go ahead and do another 3-digit number. 492. That is divisible, let's see, 11, 15. That number is divisible by 3. Because it's 15. So that's your simple trick of the day. Add up all the digits. Okay. So that is and, or, and not. So the last thing I should mention, though, is that Python is very, very smart. Is smart about evaluating, by the way. So, for instance, if I put in 100 over here, if n mod 2 is equals 0, so it's going to detect that 100 is an even number, right? No problems there. 100 is an even number. Goes and detects it, and because it detects that and it's in part of an or statement, it says, well, this is true. It doesn't matter what comes after this because it's an or statement. If since I already found it true, the entire thing's going to be true, so I'm not going to bother checking the other side. This is a feature called short circuiting, and it's pretty much it's basically standard in every single programming language. Just useful to know that that's going to happen. And you can take advantage of that a lot of the time to just simply have your code be shorter. All right, finally, we will look at the last Boolean expression operator in the next video, which is really cool.